I'm Anil Kumar, and in this video we will learn how to sketch graph of a polynomial function from the given description. So we have two examples in this video to discuss. Question is, sketch graph of a polynomial that satisfies each set of conditions. So we will discuss two graphs. As I said, the first set of condition is given to you as degree is 3, negative leading coefficient, 2 zeros, 2 turning points. The second set of conditions is degree is 4, positive leading coefficients, 2 zeros and 3 turning points, right? So that is the graph which you need to sketch. You can pause the video, sketch the graph, and then look into my suggestions. Now in such questions, we could sketch a variety of graphs, as we have freedom of selecting any zero and the turning points could be at any place, correct? So I'll sketch one and our answers may differ. So let me just draw horizontal x-axis. It is important to start with horizontal x-axis, and second, my suggestion is, it is not a must, that if we use the turning points on the x-axis, then it becomes easier to write down the equation. At times, you may be required to write down equation of the graph which you have sketched. It helps. Okay. Now, we are saying degree 3, and let's say this is our y-axis. Now, when we say degree 3, it means that the function is odd degree function, correct? So, we are looking for odd degree function, degree 3. That means opposite ends. That is the end behavior. Opposite ends. Right? So that's kind of description. Negative leading coefficient. Negative leading coefficient is right side is down. Right down. Right side is down. So opposite ends, right side down. And that combination means the graph end behavior kind of like this. Right side is down and it has to go to the opposite ends. So that is the end behavior. 2 zeros and 2 turning points, right? So it has to cross this or touch it 2 times, and twice it has to turn. While a degree 3 will always have even number of turning points. So that description is perfectly fine. And now let's see how it can have 2 zeros. If I go from here, cross the line, 1 0, right? And if I go like this, 2 zeros and turn, we get 3 zeros, not 2. To get only 2 zeros, we have to turn from the x-axis itself. So we could write like this. We can draw like this, right? So we turn here and then we go like this. So that becomes the graph of the function. In case you have to write down the equation, just in case. In that case, it is important that you can mention this as kind of -1. This you could write as +2 and give some value of y-intercept, so that you can find the equation, right? So we are not getting there now, right? But this is the graph of our function. We'll call it f of x. So this graph represents degree 3, negative leading coefficient, 2 zeros and 2 turning points. Now let's do the next one, which is degree 4, positive leading coefficient, 2 zeros and 3 turning points. So degree 4 means same sides, right? So degree 4 is even degree. End behavior, you have to look for end behavior basically to start with, right? Behavior is both are on the same side. Positive leading coefficient means right up. Right, so now we can begin sketching. We know right side is up. Both are facing the same sides, correct? 2 zeros and 3 turning points. So that means it has to turn like this. 4 means 2 zeros, and that makes sense, right? 3 turning points. Okay, so let's just sketch it. We have a graph which is kind of like this, turning like this, and then goes up. So that becomes 2 zeros, right? And we have 3 turning points to get an idea. Right? So we can write this as, let us say this point is at -1, this one is at 5, correct? That is our x-axis, and that is the function f of x, which is as per our description, right? So end behavior really helps us to draw the graph. When you're given the degree and the leading coefficient, find the end behavior and then apply the other conditions to sketch the graph. That is my suggestion. I'm Anil Kumar. You can always subscribe and share my videos. Thank you and all the best.